So here's a quick review of the course for preparation of your exam. So first thing is the basic definitions. Dynamic pressure is half rho v squared. Coefficient of lift is lift divided by dynamic pressure into area, or W over S into 1 over Q infinity. Same is the case for CD and coefficient of moments. You should know these things. The speed of sound is under root gamma RT. This is the speed of sound. You should know what is Reynolds number and what is Mach number. Then the lift curve, we have already covered it in the beginning of the course. We already know some things about it which are not here. For example, the zero lift angle of attack is to the left of the zero angle of attack because of the camber, right? So if I draw a line over here, this means that this particular airfoil is uncambered. You should know that, all right? Similarly, a high lift device will move this further. A flap will move this further to this side, somewhere over here. So how does a flap work? You should know that. You should be able to see the lift curve slope, and if I draw two lift curve slopes, one over here and the other one which is to the left, and ask you how does this happen, you can tell me that it was because of the flaps. All right. Then are the factors that change the lift curve. This is what you have covered in your first exam as well. So various types of effects. If it's a higher aspect ratio straight wing, the lift curve will go down. All right. Subsonic high aspect ratio straight wing, incompressible. When the flow is compressible, which means that the Mach number is above 0.6 or 0.7, we can use this equation. For supersonic high aspect ratio straight wing, this is the equation, and low aspect ratio straight wing, this is the equation. All right. The first thing that we do whenever we are doing this thing, factors, is to determine the initial lift curve slope, which you have done previously, A0, and find out A0 over pi AR. This thing is important because this thing comes in repeatedly. Okay. So these are the equations. You might have to use one or more of these equations and just give me the answers. All right. Now for swept wings, this is the equation for subsonic, and for supersonic, as we did in the first exam, we use these plots, right? So you have the lambda, which is the ratio between this length, root tip, and root chord, and the tip chord, which is lambda, right? And then you have various for A10 lambda LE, all right? So there are various one of them. We have used this before. You either go to one side or the other depending upon your value of tan delta LE over beta. All right. So remember this equation. Remember these plots. There might be one question from this plot. It should be easy. You did it in your mid-semester exam. So go through the same question. It will be something similar to it. All right. Now drag. Basics of drag is that we have K3, which is 1 over pi E aspect ratio. K1 is 1/3 times KE, K3. And K2, this is something that we have not used. K2 is usually equal to m square minus 1 over 4. This is for the subsonic cases, right? Wave drag. So supersonic cases, sorry. All right. In the propulsion chapter, we covered it in the mid-semester exam. There are different types of engine. Look at the schematics of various types of engines, especially the turbofan and turbojet. You should be able to look at the schematic and find out the difference. All right. And then there is the velocity and altitude variation, thrust variation because of velocity and altitude for various types of engines. This is on page 186 of the book. You don't have to read everything, but you should know how altitude changes the thrust. All right, this is something that we covered in our assignments as well. Then there is the steady flight. We already know that drag is equal to q infinity s cd, or q infinity s times cd naught plus kcl square, and lift is equal to half rho v square scl. Cl is equal to 2 times weight divided by rho v infinity s. This is all from the same equation. From this equation we get this equation. All right, and then we have determined that v infinity, or the speed, is equal to thrust to weight ratio into wing loading plus minus wing loading under root thrust to weight ratio square minus 4 cd naught k divided by rho infinity cd naught whole raised to power 1/2. So if I give you a case, you should be able to tell me what are the two speeds at which it can fly. All right. We already know that L by D max is equal to 1 over 4 k cd naught under root. This equation is important. This thing is L by D max is used repeatedly in different places, and thrust to weight ratio minimum is going to be the reciprocal of it. All right. So you should be able to tell me what is the velocity for minimum thrust for any case. All right. So I will give you the density, cd naught, thrust to weight, or maybe this thing you can find from here and tell me the minimum thrust speed. All right. So this is the steady flight. Minimum thrust required is L over D max is equal to CL over CD max is equal to 1 over 4K CD naught. Minimum thrust speed. So what we need for maximum endurance and what we need for maximum range. Now remember, here maximum endurance, this thing is for prop jets, all right, propeller driven airplanes. For turbojet and turbofan, we use L by D max, right? So this is the maximum endurance for turbofan and turbojet. This is the maximum endurance for propeller driven. Turbofan and turbojet, this is the maximum endurance speed. Okay, and again, maximum range, these equations. So I will be giving you equations, of course, but you have to figure out maximum range. All right, so these equations will have a maximum range title to it. You can use that. Maximum endurance, remember, this is the maximum endurance for turbojet and turbofan. All right. Then was the minimum and maximum velocities. Again, once again, you should know what is the pressure, the power variation with density, with the thrust variation with density, and for minimum velocity, you should be able to tell me what is the stall speed if you are given CL max, right? So if I give you CL max, you should tell me what will be the stall speed, right? Rate of climb and glide. This is something that you have just done in your assignment. This is what you have done. All right. Well, no, you have done the velocity part of the rate of climb. This is the minimum glide angle speed and minimum sink rate speed for glide. These two you have not done in your home assignments, but obviously I have to ask a question about them. So you should know minimum glide angle velocity and minimum sink rate velocity, how to calculate it. All right, for range calculations, we have not done it. I'll give you the numbers, values. You can tell me what is the range, all right, and what is the endurance. So here is the endurance formulation. Over here, L by D max, all right, L by D max. So you'll be given coefficient of thrust or thrust specific fuel consumption, CT. You have to find the L by D max, which is of course something that you already did a couple of slides back. The range equation, you can comfortably put in the values if I tell you the empty weight and the full weight, and you should tell me what is the range, etc. Right. Then next is the level turn. This is your current assignment. And max, how many G's the aircraft can pull. What is the maximum, absolute maximum number of G's it can pull. All right. What is the turn radius in level turn? and what is the minimum turn radius, right? So if I tell you that the aircraft is pulling 3 Gs, tell me what is the turn radius, all right? This is the speed. You should be able to find Q. Q is equal to half rho V square, right? So you should be able to find Q infinity and use the G as 9.8 or 32.2 depending upon which system we are using, and use this to give me the minimum turn radius or the turn radius, right? And then is the pull up and pull down. For pull up, this is the turn rate, this is the turn radius. For pull down, this is the turn rate and turn radius. So that's all. Go through these slides, all the equations there are, how to use them, get familiar with your calculator once again. You can go through chapter 5 and chapter 6 videos and notes one more time to prepare for the exam. It wouldn't be very difficult. I believe you should be able to do it in about 1.5 hours, even though the time is 2 hours. But I will be there, obviously. So if you have any questions, we can talk about it in the class while the exam is going on. If there's some problem in the paper that you don't understand, I can help you with that. All right. Go through the whole course. Obviously, this is a final exam. You have to go through the whole course. Go through the different chapter 5 and chapter 6 slides one more time, and you'll be good to go. All right. Good luck, and see you in the paper.